Jen Perron, Climate Policy Fellow with the California-China Climate Institute, and we're delighted to welcome you here today to discuss new research on decarbonization pathways for the US and China. This week, we are releasing two new reports that are reviews of the latest literature on how to reach long-term carbon neutrality goals, one for the US and one for China. Before we get started with today's program, I'd like to mention a few quick housekeeping notes. Today's discussion will last approximately 1 hour. The event is being recorded and will later be available on our website, ccci.berkeley.edu. During the interactive portion of our discussion, if you have a question, you're welcome to enter it into the Q&A field at the bottom of your screen. We'll attempt to answer as many questions as we can live. And now I'd like to turn it over to our first speaker, Dr. Fritz Karl, a research affiliate with the California-China Climate Institute and one of the co-authors of the US report. Fritz, I'll turn it over to you for some opening remarks.
Thank you, Jen. And thank you all for joining us this evening in the US and this morning in China. As Jen mentioned, my name is Fritz Karl, and I'm a research affiliate with the California-China Climate Institute. I wanted to start off by giving a bit of motivation for the two reports and laying out some guiding questions to be thinking about during the presentations. So first, a bit on motivation. Heading into the UN Climate Change Conference in November this year, we actually have a surprising amount of global motivation, global momentum around tackling climate change compared to where we were just 5 years ago. The most obvious sign, I think, of this momentum is the growing list of countries that have made or are contemplating mid-century climate or carbon neutrality commitments, in line with what countries signed up to in the Paris Agreement. But now comes the really hard part. Globally, how do we actually deliver on these commitments? There's a longer-term dimension to this question, kind of thinking out 30 to 40 years into the future, but there's also a nearer-term dimension. What do we need to do over the next decade? On both of these time horizons, the US and China are really the critical prime movers. The two countries were in many ways responsible for the Paris Agreement, and they will need to continue to drive the policy, technology, and manufacturing innovation necessary to reduce emissions on the pace and scale implied in the Paris Agreement goals, both to reduce their own emissions, but also to bring down the cost of new technologies for lower and middle income countries. So this question of how the US and China can achieve deep reductions in emissions over the longer term and what that implies for the kind of changes needed over the next decade is really central to the story of how the world will address climate change. In reality, there's already been quite a bit of thinking about how the US and China could achieve deep reductions in greenhouse gas emissions or even net zero emissions by mid-century. So toward the end of last year, we developed this Getting to Net Zero project to better understand what recent studies imply for what the US and China should be doing individually and what they should be doing together to reach their carbon neutrality goals. This work culminated in 3 reports, individual reports examining decarbonization pathways in the US and China, and a synthesis report exploring ways in which the US and China can coordinate their efforts around carbon neutrality. We released the synthesis report in early May, and that's available for download on the CCCI website. But tonight's presentations will cover the China and the US reports. We used 3 overarching questions to frame the reports, and these are the questions that I want you to keep in mind as we go through the presentations. First, what are the key changes in technology and society that would be needed to achieve mid-century carbon neutrality target goals in the US and China, and where are there policy and technology gaps? Second, where are there similarities and differences between the US and China in terms of technological change and gaps? And then lastly, where are there opportunities for the US and China to work together? A fourth question that we'll come back to at the end is the question of what next? How do we sustain current momentum in the lead up and following the Glasgow Climate Change Conference in November? So with that introduction, I'll pass back to Jen to get us started on the presentations.
Thanks so much for that opening, Fritz. And next we'll hear from a selection of the report authors for each of the papers. For the US paper, we have Amber Mahone, partner at Energy and Environmental Economics, otherwise known as E3, And for the China paper, we'll hear from Dr. Nan Zhu, leader of the China Energy Group at Lawrence Berkeley National Laboratory, and Nina Zenkana, who is a principal scientific engineering associate also with Berkeley Lab. So we'll begin with Amber and then proceed in that order.
Great, thank you, Jen, and welcome everyone. I'm just going to share my slides and then dive in. So hopefully everyone can see that now. As Jen mentioned, my name is Amber Mahone. I'm one of the report authors of this study on getting to net zero in the United States. The lead author on this, Raleigh Loken, who is also with E3, was unfortunately unable to attend, but Fritz Karl, who you just heard from, was also a study author. And in this study, we took a review of recent literature on studies getting to net zero in the US and in California and New York. And we also looked at studies aimed at achieving 80% or more greenhouse gas reductions by mid-century. So that was a total of 7 deep decarbonization studies that we reviewed, as well as a number of sectoral specific studies. And through this work, we were really looking to pull out key themes and commonalities, as Fritz mentioned. The areas of focus were really around the strategies and milestones. So what technology strategies, what technology milestones are needed to achieve carbon neutrality or net zero in the United States by mid-century. And we also wanted to identify policy and technology gaps. And I've been looking at deep decarbonization studies through my own personal work, starting with studies looking at 80% reduction by mid-century. Now we're focused more on net zero by mid-century. And so I'll also try to draw out some of those additional policy and technology strategies that are needed to get that last 20% carbon reduction. So by way of background, California, New York, a number of states have been leading in setting net zero carbon targets. California was the first in 2018. There are now a total of 11 states in the country that have set net zero targets, either in statute or through executive order. And there's a total of 20 states that are aiming to achieve 80% or greater carbon reductions by 2050. So the federalist structure in the United States has really allowed, some innovation and pushing of the envelope by states, but we have yet to see a binding emissions target from the US. The Biden administration has set a non-binding target of achieving carbon neutrality by 2050. That was back in the beginning of this year. And then just recently in April, the Biden administration has announced a target of a 50 to 52% reduction below 2005 levels by 2030. So ambition is there. The question now starts to become, well, how do we get there? A few new policies or announcements that have happened actually since this study was published. Just recently in California, the governor issued a letter to the California Air Resources Board asking them to investigate, as part of their planning process, an achievement of carbon neutrality in the state by 2035, which is 10 years earlier than the current goal of carbon neutrality by 2045. Other states have continued to increase their ambitions, and we're looking forward to further action from the federal government. So by way of summary, across the studies that we reviewed, we see a few common themes, or we think of these as low regrets or no regrets strategies to achieving deep decarbonization. The first is electrification and energy efficiency, and that's across the entire economy. That means electrification and efficiency in the building sector, in the transportation sector, in the industrial sector. Not universal, but opportunities are there and tend to support decarbonization strategies regardless of what scenario we evaluated. Clean electricity is absolutely essential. And what that means is deployment of renewable electricity as well as storage. We see also a need for zero carbon capacity. And I'll speak to each of these in a little bit more detail on the subsequent slides. Low carbon fuels is the third pillar, and that is necessary for sectors that are difficult to electrify. And that can come in the form of things like renewably produced hydrogen, as well as advanced biofuels and other synthetic low carbon fuels. Reductions in non-CO2 and non-combustion emissions are also essential. And this actually is one of the more what we think of as low-hanging fruit opportunities in the United States. Replacing hydrofluorocarbons, HFCs, is a great low-hanging fruit opportunity. And then the fifth pillar, the final pillar, is carbon capture, usage, and storage, otherwise known as CCUS, and enhanced land sinks. And this is an area where we're seeing greater focus as we move towards net zero targets. So just to briefly walk through each of these, when we look across electrification, these panels show buildings, transportation, and industry. We see a need for increased ambition as we move from today, which is 2018 here on the left, to an 80% reduction to a net zero target. And these show the ranges of electricity that is providing energy across each of these sectors and across the sectors that we evaluated. In terms of clean electricity, again, this shows a similar progression from today. We have about 10% of our electricity is so-called clean, coming from wind and solar. And to achieve an 80% reduction, that has to get to the 50 to 60% range. And to achieve net zero, that requires a minimum of 70%, potentially up to 90%, with that last 10% needing to be met by firm zero carbon energy and capacity, which may come in the form of hydrogen, or maybe some new emerging form of long duration energy storage or biofuels. In terms of low carbon fuels, I mentioned these are necessary to decarbonize hard to electrify sectors such as aviation or shipping, high temperature industrial processes. This figure shows the share of final energy demand across the entire economy that is met by different energy types. The dark blue shows electricity, and I mentioned previously that the share of electricity needs to increase in all low carbon scenarios. But the yellow and gold there represent low carbon fuels, either electricity derived fuels such as hydrogen or synthetic fuels, or biomass fuels to decarbonize those other hard to electrify sources. There's obviously uncertainty here and ranges across the scenarios, but we know that we're going to need research and development in bringing these fuels to commercialization. In terms of non-CO2 and non-combustion greenhouse gas emissions, this figure represents this sector of emissions in the US today. You can see that the largest source is coming from both methane, CH4, and nitrous oxides, N2O, in the agricultural sector. Those are challenging sources to reduce. There are technologies and startup companies that are working on those, but we see less opportunity for achieving the 80 to 90% reductions within this non-energy, non-combustion sector, which means that reductions in CO2 emissions from fossil fuels will need to be that much greater in order to achieve carbon neutrality. And we see that we will need to have negative emission technologies and carbon capture sequestration to offset some of the remaining emissions from these sources that we can certainly mitigate, but we may not be able to fully eliminate by mid-century. In terms of carbon capture, usage and storage, and enhanced land sinks, this is the last and fifth pillar that is essential to achieving net zero emissions, because these sources remove or offset the remaining emissions that, again, may be difficult to fully mitigate by mid-century. So this figure shows just carbon reductions from natural and working lands. You can see the net CO2 sink from natural and working lands in gray there in the United States today. Just maintaining that sink actually requires significant efforts and policies. Increasing that sink is certainly a goal, but will be challenging. And even this level of carbon sequestration in lands won't likely be enough to offset the remaining emissions in the economy and achieve net zero. So we will also need to commercialize carbon capture, usage, and storage technologies, or otherwise known as negative emission technologies. So that's a lot. That's a lot that will be needed in terms of technologies and deployment across all sectors of the economy. We identified 4 key policy actions that are needed today in order to help enable that technology transformation. And the first is to align economics for customers and companies. We see the Biden administration is proposing certain incentives and tax credits. We'll also need to continue investing in research and development, and keeping a lens and focus on affordability and equity will be a key piece of how do we align economics. It's not just for the whole economy, it's really at that distributional level, who's paying and how. Secondly, we'll need to align the policies and institutions to remove barriers. So, one example of this is the massive scale up of renewable generation that will be necessary to achieve those clean electricity goals. We see barriers to siting transmission and barriers to siting renewable development that will need to be addressed in order to achieve that scale up. We see infrastructure planning around EV charging, electric distribution upgrades. So there's a number of areas that will be useful here. Thirdly, increasing consumer awareness and education. This transition, particularly towards electrification and energy efficiency, requires consumer participation. We're talking about the types of appliances that you have in your home, the type of car that you drive. So there's consumer choice questions here that will need to start shifting fairly rapidly in order to achieve these high levels of electric technology adoption. And then finally, creating a transition plan for the fossil fuel jobs that we are transitioning away from. This we see as an important part of the political strategy. We've seen some efforts to address the transition in the coal industry, but oil and gas is also top of mind here as well. So I thank you very much for your attention. I mentioned the study authors, and I appreciate their great work on this. My contact information is listed here if you have any questions about the report. And finally, I'd like to acknowledge the reviewers of the report and the Hewlett Foundation, which was the study sponsor. So thank you very much. And with that, I'll turn it back over to Nan, and then we'll have time for questions at the end.
Good afternoon, good morning, everybody. Very happy to be here again. I think some of you participated in our earlier webinar and on the census report. And you just heard from Amber about the US review of the carbon neutrality and targets and studies. So this one, and I'm going to talk about together with my colleague Nina Khanna, is focused on China. Just to give you a little more background, this study was conducted with this hypothesis there must be something, could be common theme or technology area or policy or even milestone, and potentially US and China could share experiences and maybe coordinate on some of those deployment or even development of some of those carbon neutral technologies. So this study we have conducted with support from CCCI and also with the Hewlett Foundation support. It gives us an opportunity to look and at a number of studies being undertaken by both Chinese institutions and international organizations, looking at in the 1.5 degrees C or 2 degrees C scenario for China and evaluating pathways and for China to achieve those carbon neutrality by 2060 or by 2050. Next, please. So a little bit of introduction. I think some of you are very familiar with our China Energy Group work, some may not be. And the group is within Lawrence Berkeley National Laboratory, and they've been around for more than 30 years. And in the past, we delivered quite a number of significant policy impact and successes in transitioning energy system into a clean system, and also improving efficiency, help China to build a bridge with international institutions, and also collaborate with international institutions. So here's some basic introduction of the group, 12 staff members, dedicated to research related to China, energy and climate change issues. We also have a very robust visiting scholar program, and on annual basis, we welcome 20 visiting scholars from everywhere from China. This had been the case until really COVID hit us. And also data has been one of the key assets of the group. We have data and data all the way back to 1949 related to end-use sector energy use and supply, production, transformation, many of those, and a model we use to project and conduct scenario analysis for future. And we produce this annual China Energy Outlook that documents historical trends year after year and targets programs, policies being implemented, and future scenarios. Okay, next, please. So this report on China, and we have conducted is a comparative analysis of the mid-century scenario published between 2017 and 2020. This is right before a Chinese president announced this 2060 carbon neutrality goal. And as mentioned earlier, and part of the purpose is to figure out the magnitude and the pace of energy and CO2 emission reduction, and through what kind of technology or policy pathways and for different sectors, and the scale of the electrification, the fuel switching, and technology deployment and development needs, and similar approach, and that E3 and also conducted for the US study, and to be able to draw kind of conclusion for the area US China could really coordinate or collaborate. Next, please. So we reviewed 8 studies and covered 10 scenarios. The table on the right and shows the details of these different studies done by either Tsinghua University, the Institute for Climate Change and Sustainable Development, or Energy Research Institute under NDRC, or Energy Foundation also has conducted census report and compiling and modeling scenario from 5 or 6 and research institutions work for the similar topic. And then also we have included our own scenario and based on our China Dream model, as well as the Energy Transition Commission and Rocky Mountain Institute study, and for the zero carbon economy. And then you can see they're a little bit more detailed. They have different names, mostly and compatible with either 1.5 degrees C scenario or 2 degrees C. And then a number of the studies also provided the policy analysis and the recommendation besides the technologies area. And so what they found in general is that there are final energy and use could peak by different years. And also there's CO2 emission and has different peaking year and a reduction. And could you please go back just a little bit? Sorry. Yeah, and so and also illustrated these different decarbonization strategies in the area listed here, very similar to the US report introduced earlier. The policy recommendation include economy-wide supply and demand side. Next, please. So I just quickly and show you some of the high-level findings, and then we'll turn over to my colleague Nina Khanna to give introduction on more detailed finding. So very quickly on the final energy consumption, and you can see through the various studies, and in general we found final energy likely to peak by 2025 for the most the 1.5 degree scenario. Or if it's for 2 degree scenario, it needs to be peaking by 2030. And the ranges from roughly is a flat of 30% reduction from today's level. This is quite significant if you know the historical trend for final energy consumption in the last 2 decades. We're talking about China needs to really peak soon and started going down, and this is a final energy, not talking about and decarbonization for the power sector yet. And so there's a lot of an area that still needs quite a bit of both policy and technology effort. Next, please. If you look at the CO2 emission and trajectory, and this is even more astonishing, it shows for the 1.5 degrees C and compatible this target, China's CO2 emission needs to already have peaked by 2020. So that's mostly shown in the green lines and in the green range. And then for 2 degrees C compatible scenarios, basically CO2 emission needs to peak by 2030. But before that, it needs to reach somewhat a plateau. And then right around 2030, it needs to have this very steep drop, 2030 to 2040. And the end point is to achieve carbon neutral in 2050. And we found the most of study and that also utilize significant amount of negative emission technology assumptions that introduce a lot of uncertainties. And I think Nina will talk about that later. So with that, I will hand it over to Nina and to give a little more detailed and introduction of the research findings.
Thank you, Nan. So following what Nan has laid out in terms of the deep, but also very diverse energy and CO2 reduction pathways that's needed for China to strive towards this carbon neutrality goal, I will introduce some of the key common decarbonization strategies that we identify from these pathways, which are very similar to what we heard from Amber on the US decarbonization pathways. But I think some of the key takeaways and milestones are a little bit different in China's context. So the first strategy is energy efficiency and energy demand reduction, which has been a cornerstone of China's energy as well as climate policies recently. And in most of the studies we review, there's an expectation that near-term energy efficiency improvement will continue at a pace that's at least consistent with recent policy-driven trends. But there's also some recognition that significant efficiency improvements may be more technically limited in the long term as technologies approach international advanced levels. So for example, in the building sector, where there is the highest forecasted energy consumption growth, the continual adoption of high efficiency equipment can reduce building energy consumption intensity by 50 to 60% by 2050. But then in the industrial sector, where energy efficiency levels actually already quite high in some specific industries, such as cement and steel, there's less potential for efficiency improvement out to 2050. And then for other industries such as chemicals that's more diverse, there's still slightly larger efficiency gain remaining out through 2050. And in addition to this technical efficiency improvement, another area where these studies saw that energy demand reduction could be possible is through macroeconomic shifts and societal shifts, such as structural change in industry, improving utilization efficiency of raw resources and materials, and promoting more circularity, as well as urban planning and adopting more low carbon lifestyle changes in society, and integrating innovative technologies such as big data, digitalization, to support energy demand reduction across all end-use sectors. And then the second pillar is really electrification in parallel with power sector decarbonization. So in all of the studies we review, as you can see on the table on the right, there's expected to be a significant increase in electricity demand from about 7,500 terawatt hours currently to anywhere between 11,000 to 17,000 terawatt hour by 2050. And this translates into economy-wide electrification rates of between 40 to 70%. And there's quite a range because it really depends on different studies' outlook for more expensive and uncertain technologies, which also range across the different sectors. So for buildings, there's already multiple commercialized technologies that are available as electric alternatives for heating, water heating, and cooking that have traditionally relied on fossil fuels in China. But even with these alternatives, there's still the challenge of how to electrify district heating in urban areas in China. And then in transport, we really saw from the studies that there's a dichotomy in the electrification potential between the relatively well-known applications in electrifying rail and road transport, but much more uncertain potential for electrifying shipping and aviation. So this leads to a range of 33 to 57% electrification in 2050, even for the 1.5 degree scenarios. And then similarly in industry, most of the existing analysis focus on several of the key, most energy intensive sectors and what are the technological options for electrifying those industrial processes. But we can see that there's still a lot of uncertainty resulting in this electrification potential of anywhere between 48 to 73% for industry in 2050. And as mentioned, power sector decarbonization and having this clean electricity supply is definitely essential to supporting electrification and overall economy decarbonization. So we noted that for many of the 1.5 degree compatible pathways, they're actually expecting non-fossil generation shares upwards of 90% by 2050. And we can see that from the chart below by looking at the different shares of the different fuels. So of this non-fossil generation, solar and wind are definitely considered to be the most important. And the study saw that combined generation share from solar and wind could increase from only 9% today to anywhere between 34 to 73% by 2050. And this really implies, as Amber has mentioned, a very significant scale up in terms of the renewable capacity that's needed to provide this generation. In China, in terms of scale, this means kind of doubling the current total capacity in a span of less than 5 years. And then from there on, increasing both solar and wind individually at a pace of 130 gigawatt per year, each year through 2050. And just to kind of put that into perspective, that's about the equivalent of adding double North America's total installed capacity for solar and North America's total installed wind capacity on an annual basis each year out through 2050, which is very significant. For nuclear, I think the study saw different role for nuclear. There was less consensus on its future outlook, but it's definitely remaining within the power system, even out to 2050. And similarly for coal or natural gas, most of the studies saw a very limited role for their generation and expect most of that generation to be equipped with CCS by 2050. The other major future strategies include alternative clean fuels, including biofuels and hydrogen, as well as CCUS. So for biofuels, biofuels is really seen as an alternative to oil products for replacing shipping and aviation transport. Whereas hydrogen, there's varying degrees of utilization seen within industry as a potential feedstock replacement, and also for utilization in transport to decarbonize low-haul freight transport and shipping. But within China, there's relatively limited bioenergy resources. So that means its deployment will really depend on sectoral prioritization. And of the studies that considered this, they saw that its role to be less than 20% of energy consumption by 2050. Similarly, for hydrogen, its role is also limited to only about 10% or less by 2050 in the studies that consider hydrogen. And this is really due to the uncertainties in both the timeline, but also the cost and feasibility of scaling up hydrogen production that's using renewable electricity. And it's important to note that if the supply of these alternative low carbon fuels is lower than expected, then there's higher electrification that's needed in order to kind of decarbonize the entire economy. And this is kind of where carbon sequestration is seen to play a role to really capture the remaining CO2 emissions in order to approach net emissions by 2050. So several scenarios did include about 1 gigaton of CO2 sequestration by 2050, as well as consider net carbon sinks through agriculture, forestry, and other land use sinks. In terms of remaining uncertainties and other gaps, one of the key areas that's unknown is really whether progress can be made around industrial structure that's needed to decouple economic growth and energy consumption growth as China continues its transition. And this is really important given China's continued urbanization as well as its continued role as a global exporter of manufactured goods. So we can see from the chart on the right by the orange portion that historically it's been very difficult to reduce the industrial sector's share of value added in China's total GDP. And that's actually remained relatively constant from 1990 through 2018, despite a lot of policy effort focusing on trying to promote industrial structural change. There's also a lot of uncertainties around costs, both for cost reductions and investment costs needed to support the deployment of commercialized technologies, but also the cost that's needed to research, develop, and deploy the scale-up production of non-commercialized technologies. And then from a societal perspective, how to model lifestyle and behavior changes and the role they can play in terms of policies is also another major area of uncertainty in these studies. And there are also, as Amber alluded to for the US studies, broader climate change implications related to non-energy CO2 and the role for terrestrial sequestration and non-CO2 emissions as well. And then quickly on policy recommendations, all of the review studies included policy recommendations or indicative policy goals for 2050, as Nan mentioned, but there's really missing how specifically to close the gap between these near-term actions, with many of the studies providing near-term actions that's really focused on the 14 five-year plan from 2021 to 2025, or focusing kind of on the long-term end goals for 2050, but how to kind of close the gap between these near-term actions and long-term goals is really missing. So a limited number of studies provided some specific policy recommendations at the sectoral level, but we really see kind of this entire time horizon as a key area where more policy recommendations could support the technology efforts that's been identified by these scenario studies. So with that, I'll just turn it back over to Nan to close out the presentation.
So just a number of relevant publications, and to reiterate what I probably said earlier. There's this census report we published about a month ago. and it's available for download on website. And there's this US report Amber just introduced, and then this one we just and talk about on China, and are all available for download. At the same time, and our China Energy Group published this China Energy Outlook, and on the right hand side you can see a cover page of the 2020 version of that. And in a month or so, and we'll have our 2021 edition, and we'll be very happy to share with you, and then that will cover a lot of most up-to-date and data on energy and the emissions, and also new scenario that will and explore carbon neutrality and pathways and roadmaps for different sectors. Okay, next, please. Yeah, so lastly, and I want to also express our gratitude to CCCI to provide our opportunity to be part of the team conducting the analysis, and also thanking Hewlett Foundation to provide and the funding and for the research. And here's the 3 team members. Nina is the first author and for this particular report, and then Lynn Price is our senior advisor and very instrumental in conducting this analysis. With that, and I will hand it over back to Jennifer.
Thank you so much to you all for those insights into the key findings of these reports. And now we're gonna begin our audience or interactive portion of the program with audience Q&A. So if you do have a question, you're welcome to type it into the Q&A function, which is located at the base of your screen. And we'll try to answer as many of them as we can live. To get us started, so China released its 14th five-year plan earlier in this year. And I know the China report offers some analysis of the targets that are included in that plan, and some of the longer term goals that are also needed. Can you tell us a little bit more about kind of what's needed in the nearer term and the implications of this research for China's 14th five-year plan?
Nan, did you want me to answer or?
Yeah, go ahead first, yeah.
Okay, sure. Yeah, that's a great question, Jen. Thank you. So I think, yes, we saw coming out of a comparison of these studies that there were definitely, policy recommendations, as well as kind of, understanding what the long-term trajectory is and kind of indicative goals for reduction, both on energy intensity as well as CO2 intensity for China during this 14th five-year plan, which is essentially the next 5 years. So there's actually, as we saw, I think from the chart that Nan had discussed on the CO2, there's quite a bit of a range in terms of, the reduction goals that have been offered. So some on the lower end, we're looking at energy intensity goals, for example, a 14 to 15% reduction over this 5-year period, but other scenarios were a bit more aggressive, offering 19% reduction, for example. And we see that similarly for CO2 intensity as well, ranging from 19-20% reduction to 27%. So China's 14th five-year plan has been, the goals that's been announced has been a little bit more conservative compared to some of the numbers that we've seen coming out of these studies, in terms of the intensity reduction target that's been offered at 13.5% and 18% for CO2 intensity reduction. But I think, again, it kind of speaks to the question of, this really focus on near-term actions, but understanding that after this 5 years, there's still a lot of, time remaining, a time horizon where there needs to be a lot of additional policy support as well as accelerated action. So I think it's kind of taking that into consideration that, yes, while the targets for now may not be as aggressive as some of the other scenarios have shown, but given that there's still a lot of remaining time, it's really focusing on the years, from 2025 to 2035 to 2040. I think that there's still a lot of room in terms of policies that can influence the uptake of some of these technologies that we've mentioned from the different reports.
Jen, I'd also like to add that there is an emphasis on peaking CO2, either toward the end of the 14th five-year plan or early in the 15th five-year plan period. And that peak, which will be, before 2030 as committed by China, will be led by a peak in the industrial sector. And there are a number of industrial sector associations that are studying this right now and making commitments to peak their CO2 emissions by 2025 and sometimes even earlier. So this peaking that we looked at overall will be led by the industrial sector, and that will happen in this 14th five-year plan period.
Thanks so much to you both for your responses. So switching gears to kind of the US analysis. So we have a question about the US analysis and clean electricity and whether advanced nuclear is included in the zero carbon firm capacity calculations. And if so, what percentage is included?
Yeah, so advanced nuclear has certainly been contemplated and considered as a form of zero carbon capacity in some of the scenarios that we evaluated. It's not included in all of them. The nuclear fleet in the US right now is facing serious challenges with economic competitiveness, and the cost of building new nuclear is much higher than some other alternatives that are being contemplated. So it's seen as sort of a potential solution if that advanced nuclear technology can kind of cross the threshold towards commercialization. The scenarios that we evaluated looked at between 90 and 95% carbon reductions from renewables and hydroelectric generation, generally showing that last sort of 5 to 10% needing to be met with some form of zero carbon firm capacity. So advanced nuclear could certainly play that role, but the other technologies competing to fill that are also, I guess, potentially more competitive, at least based on what we see today.
Okay, thank you. And another one for you, Amber. So we have a question about the amount of sequestration that would be needed to meet a net zero goal in the United States.
Yeah, that's also a great question. The studies that we evaluated looked at ranges of direct carbon reductions from fossil fuels of between 85 to 90% reduction. So we're seeing a need for negative emission technologies of between 10 to 15%. Now, what share of that is met by land sinks versus other forms of CCUS and negative emission technologies ranges by scenario, but in general, there's a sense that land sequestration won't be able to meet that whole gap, and so on the conservative end, it is a 10 to 15% carbon reduction coming from CCUS and other negative emission technologies.
Okay, excellent. And then so for China, so China last Friday, launched its national carbon market. There's a question about kind of what role such an instrument might play in reaching a long-term decarbonization goal for China.
I can quickly respond, and maybe Fritz, you can add later if there's additional information. So I think the carbon market will start with the power sector, and then it will include some of the heavy industry sector and very soon after. And it certainly can play a role in overall emission reduction. And there are also challenges being discussed widely. And does it offer really a cap and in absolute reduction? And And also, how are we doing with these industrial sector where data has been lacking and could be also challenges. But overall, it's certainly a big step forward and for this national rollout of the ETS.
Okay, thank you, Nan. We have another question about the context in China. So in addition to looking at, to add additional renewable capacity from things like wind and solar power, which many of us are familiar with, are people in China also working on using ocean power, ocean or river systems through using submerged turbines? Is that something that came up in your analysis at all as a potential technological solution?
No, this wasn't a solution that was from the studies that we review, I think because it's relatively new. So I think most of the emphasis has still been on kind of the more traditional renewables. But for example, for wind, there was an analysis looking at offshore wind as well as onshore wind. So it's not, limited to only the current suite of renewable energy technologies. But this may be an area where there might be growing interest, either from government or from industry in the near future as they're looking, as I think the question mentioned, moving from fluctuating renewables to more stable sources, but that isn't something that has come up in current analysis yet.
The key challenge in some of the new area of technology is about scalability and the speed. How fast can we deploy these, and with considering costs and other limitation, and how large and of decarbonization we can accomplish, and again will be the key question yet to be answered.
Yeah, exactly. And related to that, your analysis showed some really staggering figures about, the needed uptick in renewable deployment in China in particular, with some really staggering statistics. What are some of the barriers to doing that, whether they be technological or land use or energy transmission? What are some of the challenges to kind of scaling up renewables at the really intense scale that you've outlined?
Nina, do you want to go first?
Sure. I was just going to say that I think it's probably, I think there are some institutional barriers as well as kind of market barriers just in terms of how China's current power sector is. I think, there's still continuing work on power sector reform in order to reduce some of these institutional barriers in terms of the uptake of the renewables, with them becoming increasingly more competitive. So I think, it's probably not as much of a technological issue beyond kind of the transmission issues, but I think there are also a lot of kind of more institutional and market challenges in terms of the scale up and adoption. But I'm sure Nan and Fritz have additional points to add.
Maybe Fritz, you want to add more?
Sure. So actually last year, China in combined wind and solar, China installed 120 gigawatts. So that's actually not that far from the 130 gigawatts that Nina mentioned. I think there's a couple of big challenges. As you start adding 130 gigawatts every year, there's a couple of big challenges that both the power system will face, and from a kind of a land use regulatory perspective that I think regulators will face. From the operational perspective, wind and solar are intermittent, and so you have to find ways to operate electricity systems with very large amounts of wind and solar. I think that's going to be a challenge. But there's also questions about the land use implications of building solar and wind at that scale. And I don't think it's impossible. I think it's actually very feasible. But I think there's a process that needs to happen of both from the operations perspective and also the land use perspective of kind of socializing ideas and getting used to what this might look like, and then moving into I guess an implementation phase.
Okay, thank you guys. So we have another question about something that's also been in the news lately, a carbon border adjustment tax. So there's a question that says the US is potentially looking at implementing a carbon border adjustment tax. Do you think this would push global players to put in more efforts in decarbonization, or would it lead to trade wars or other frictions?
Well, I'm happy to take this and also welcome my other panelists to jump in. I think that it's probably too early to say whether that would be adopted. And, with trade policy, it's always the devil is in the details. I know this is something that Europe is also seriously talking about, so there's alignment there. But we'd have to see more details before speculating there. I think as we move towards achieving these decarbonization goals, this will be an important thing to figure out, our trade policies with respect to carbon emissions, particularly for trade exposed industries. But many of the sort of immediate near-term actions on decarbonization with energy efficiency and electrification, clean electricity even, are not as focused on those trade exposed industries. And so I think we have a little bit more time to figure this out for industry. Not a lot more time, as we've seen. The timeline is challenging and ambitious in all sectors. But I guess I don't know if others have perspectives on that. It's a bit speculative still at this point. I also want to acknowledge a question around, the fact that this all seems really hard. Is this even possible? And I'll note that when I've given presentations like this, there's members of the audience that always have that reaction that, this looks too hard. We won't get there. And then there's always other people in the audience that say, wow, this is amazing. There's a roadmap here for achieving our carbon reductions. This tells us exactly what we need to do. It doesn't rely on any technologies that don't yet exist. So let's get started. And I think there's some element of truth in both of those reactions. But I do want to point out the positive sides as well, that there is a technology path that relies on existing technologies to getting there. But the scaling up and deployment is absolutely a daunting challenge.
Thanks so much, Amber, and for working in an additional question in your response. So we have a very specific question about, for China's generation scenarios, there were estimates of 11,000 to 16,900 terawatt hours. The question is there a probability analysis based on current policies? Is that on the high end?
So those numbers are from these deeper decarbonization scenarios, whether it's 1.5 or 2 degree compatible scenarios that are really pushing for electrification as a decarbonization strategy. So I would say that they're probably on the high end. But I think in general, even under some of these reference or continued policy scenarios, we do expect China's electricity demand to increase just as it's shifting, particularly I think in certain areas like rural residential households, as they're undergoing the energy transition and beginning to use more electric-based appliances and equipment. So there is expected increase, but those numbers are probably on a more high end for continued electrification.
Great. And then just to counterbalance, so Amber, you brought in this additional question about looking for optimism in this, whether there's any kind of bright lights coming out of this research. So I'd be curious from any of the panelists or report authors, just what some of the lower hanging fruit were, or some of the kind of areas for optimism or encouragement that you've found throughout this research.
Sure, maybe I'll start and then turn it over to you, Nan or Lynn or Nina. A major low-hanging fruit that I briefly touched on in my remarks is actually just around ratification of the Kigali Agreement, which pertains to high global warming potential gases and in HFCs. And this is an area where we hear from industry that alternative lower global warming potential gases exist and could be deployed. There just needs to be an incentive to do so. And so I know this is an area where the Biden administration is working, but I think, we could quickly see a replacement of HFCs in refrigerants that's in your air conditioner, in the refrigerator, in your home, in the air conditioner in your car, in certain industrial processes. So that's sort of a immediate near-term action that just needs to happen. And another one is mitigating oil and gas leaks. It's a major source of emissions, and it just hasn't been highly regulated and monitored, and that would make a huge dent on our methane emissions, which again is another high global warming potential gas. So those are just two examples. Maybe I'll turn it over to the China team if they have any suggestions as well.
Yes, so I guess we could say the same for China on the Kigali Amendment and the HFC, so I don't want to repeat that. Same time, efficiency has always been the lowest hanging fruits, and we know how to do it. We've been doing that for decades. A lot of those are still not being deployed at the full maximum potential. So in all the area, whether it's buildings, industry, and maybe a little bit less on transport, there's still a lot of efficiency improvement that can be made in all these sectors. And at the same time, decarbonizing power sector, as Nina also mentioned, we know how to do it. We know how to install wind, solar, we know a lot of time they're cost effective. We just need to be able to remove some of the institutional barrier and some other technical barrier and more financial and economic barrier. If we can help reduce, those could all be done and scaled up. One thing that has not been discussed as much in all these studies that we could do more is mentioned in one of the answer to the question is demand reduction. We just cannot consume the same way we've been consuming energy in the past 100 years, and there needs to be change. That's a tricky, very difficult part, but there are things we could still do. For example, if we can improve the buildings and quality, and you remember recently the Florida apartment building collapse, but in China, and this happens quite often, the building material, their quality or construction quality, if the lifetime could be improved to 70 years from the current 40 or 30, and then we can reduce a lot of needs for cement, steel, glass, and all these building material. There's better design we can do for buildings. We know how to do net zero energy buildings already. California has this net zero targets. China hasn't implemented or announced that, but we know how to do it. Again, that's a cost issue, that's a regulatory and institutional barrier, but there are things we could do, and if we're really getting serious about those.
Okay, thank you so much. So we're coming toward the end of our time, but before we wrap up, I'd like to turn it back over to Fritz for a few closing remarks.
Thanks, Jen. So I wanted to wrap up by coming back to a couple of the questions that we posed earlier, and then close with this question about how we sustain current levels of momentum over the next year or two. So one of the things I found really interesting about these reports is how much convergence there's been between the US and China around expected technology strategies for reducing emissions, both in the near term and in the longer term. So for instance, both countries have converged around electrification as a dominant strategy for reducing emissions in transportations and buildings. In both countries, rapidly expanding solar and wind generation is a dominant strategy for reducing emissions from electricity generation. And how to significantly reduce emissions in the industrial sector is still largely an unsolved puzzle in both countries, but one that's attracting a growing amount of attention in R&D. So to me, these kinds of insights illustrate the power of long-term decarbonization pathway study. These studies allow us to get on the same page about what's possible, where we have greater and less certainty, where we need more research and development, where to focus policymaking in the near term, and how we can set milestones in individual sectors to measure progress against overall emission reduction goals. I think the convergence in technologies and challenges between US is partly a result of the open flow of ideas and at some level open trade, but also I think it's just the result of having a shared problem of climate change. And the fact that we have this shared problem and shared solutions suggests that there should be a high value in cooperation. But given all of the myriad difficulties of the US-China bilateral relationship right now, how can the two countries cooperate? In the synthesis report, as part of the series, we focused on this idea of coordination. Even if the two countries can't find ways to cooperate through traditional diplomacy, at a minimum, they need to maintain the regular dialogue that helps to coordinate policy. Coordination can help to maintain a focus on goals. It can help to build confidence and trust, foster healthy competition. And if we can maintain open borders and investment, it can bring down the cost of reducing emissions through larger markets and innovation. The US-China joint statement on addressing the climate crisis, which was released in April of this year, was a good initial step toward coordination, but it raises the question of what next? What will coordination at a bilateral level between the US and China look like over the next couple of years? In parallel, there have been some recent evolutions in policymaking that are opening up some new avenues for US-China collaboration on climate that I think are worth investing in. So in the US, as Amber noted, we still have this federal impasse on climate policy that means that most of the momentum for dealing with climate change resides at a state level. In China, interestingly, the central government has tasked provincial and municipal governments with a lot of the planning and policy making for meeting the country's carbon peaking and neutrality goals. Both of these realities mean that a significant amount of momentum for the next steps on climate policy will be at a subnational level, so states, provinces, and cities rather than at a national level. And I think this has a few important implications. First, in the near term, it means that the most valuable form of collaboration between the US and China is probably at a subnational level, focused on technical assistance, regular dialogue, and developing ways to benchmark progress. Second is that the US government and the US federal government and China's central government need to find ways to make political space for subnational engagement between the two countries. And then third and lastly is that these kinds of subnational engagements can be an important way to sustain global momentum as we move from an era of commitments to one that has to be more focused on implementation. I think our challenge now is to develop the organizational infrastructure to make these subnational partnerships more effective. So with that, I wanted to thank you all again for joining us this evening and this morning, and I'll pass back to Jen for a few housekeeping items.
Thank you so much, Fritz, for bringing in the lessons from the synthesis report as well. So I'd like to thank everyone for joining us. We really appreciate your time and hope you found this session informative. I've just dropped in links to each of the reports in the chat. With apologies, the first link was incorrect, so there's a corrected version in there. This event was being recorded and will be available on the CCCI website after the fact. And thank you so much for joining us. Have a good evening or morning wherever you are.
Thank you.
Thank you.
Thank you. Goodbye.
Thanks.